But I wanted to make a point of how remote sensing has been perceived, especially recently, as a way to do what we could call social ecological systems analysis or sustainability science from space. Because of these different technological advances, we can start to understand forest management and governance, and therefore this is the proposition within PANGEA, is how do we actually study these complex adaptive systems. Next, please. Moreover, we know, for example, if we think about these coupled dynamics between social and ecological processes in more recent times, there's a good example of a study also done in the Amazon that looks into, so if we are to explore the forest, we might expect that that will alleviate poverty in many different ways. So this paper here actually shows that transitions into certain types of land use may not alleviate what we poverty as we would expect from theory, and actually it might lead to what we call poverty traps. And in fact, in the Amazon, in this very local scale study, there are two traps that were identified. One is one trap related to the subsistence crop, and one is a trap that is related to short fallow types of rotational regimes. So this gives you an idea that over time we might have different perspectives of how humans and nature interact in tropical systems. Next, please. So in the next couple of slides, let me present a vision of how could we potentially study social ecological systems from space. So let's say we will be able to, not so far away from now, to be able to map, for example, here's a map of spectral diversity mapped with Sentinel-2 data. Next, please. Which we also can use to estimate turnover in spectra at the local scales, and with the emergent technologies that we've heard a lot about and the different missions that are occurring, we start to see the trees, the functions, their structure, and we then, next please. In order to understand the social ecological dynamics, we need to start to understand what are the processes of the people that live in the Amazon and the people that live outside the Amazon that lead to different types of dynamics. Next, please. Part of them are dynamics that relate to dealing with appropriation problems. So how much do we take out of the forest and who benefits from those? And next, please. And provisioning dilemmas of who actually provides to maintain the forest and who benefits from this provisioning itself. Next, please. In theory, when we think about coupled human natural systems evolution, this conceptual diagram here identifies that as we change in different over time, we can maybe modify our social ecological dynamic from a green loop that is based on local ecosystems with rural people and households for which the supply of ecosystem services and this service is sufficient to maintain this dynamic, all the way to what we call this red loop, as we see urbanizing systems that still depend from nature, but mostly from elsewhere. Next, please. So one way to think about can we think about social ecological systems beyond the description of the patterns and beyond recollecting data that will enable us to understand how these processes might occur, we might start also developing some theory that is based on empirical observations. And here's some work that we've been doing to try to actually capture this idea of the dynamics of the green and the red loop, and what kind of alternative stable states might we be able to find in these social ecological systems. Next, please. So if we think about a vision, we might start with having this stylized social ecological system like the one I showed you in the previous slide that is fed by observations like those obtained in PANGEA from remote sensing and other types of sensing, and use these same observations to calibrate and validate predictions of the social ecological system behavior. And then as we move towards from this stylized social ecological system kind of dynamics to more high fidelity modeling boundaries, where we actually include more context dependency, we start to be able to answer lots of questions that relate to social ecological system understanding. So with that, next slide, please. So PANGEA is centered a lot on remote sensing data. And I would just like to make a point that for every pixel that we're mapping, there is a past associated with a co-evolutionary process, perhaps, between humans and nature. Next, please. And there is a future that we might want to predict. And I hope that in the previous minutes, I've showed you how a social ecological systems approach to tropical ecosystems might work. With that, next. Thank you very much for your attention.
Thank you, Maria. All right, so we have Matt Hansen and then two more presentations after that, before I hope we'll have some time for questions. All right.
Okay. Thanks a lot. I'll be talking about our work. Mapping and monitoring forests and the drivers of deforestation. We rely on the free and open imagery of NASA, USGS, ESA. That pretty much prescribes what data are available to us, because we want to map the planet, we want to map it with a certain cadence, and there's just a subset of provisioning services that meet that standard. And with Global Forest Watch, we've been producing these global data sets. The biome of interest right now is the humid tropical forest for Pangea, and we are tracking annual loss since 2002. And my animation doesn't work, so I got to click through all these years. That's brutal. But that's a pretty good record, though. 20 some years of data. I'm tired. No, exactly. Anyway, and the story is not a good one. Over the 20 years, we have not seen a loss. It's a finite resource that we continually are appropriating for economic activity. And when we look at the overall record, there's been very few interdictions. Brazil had a success, but it was ephemeral. Indonesia has a current low level that might prove ephemeral as well. Well, I'm way ahead of things now, man. Okay, so nothing's working. Anyway, so we can look at these dynamics. This is 2023. The country is over 200,000 hectares of forest loss, with Brazil over 1 million. Going back 10 years, so just taking a time slice of comparing a decade of change, and Brazil has increased over that time. 2012, they are half of what they are today. So they get credit for bringing down the area of forest loss for compared to last year. But they, again, when you go back to their lows of the early 2010s, pretty far off. DRC, the demographic wave, 100 million people. Article 15, which means, that was the Mobutu's fictitious 15th article in the Constitution of the old Zaire, which meant you're on your own. That's what we see from the satellite in DR Congo, 500,000 hectares per year by hand. Bolivia is unique in its rate of deforestation per capita. It is knocking on the door of DR Congo at almost 500,000 hectares per year. Very much a Wild West operation. About half of that this year's fire. And then Indonesia going the other way, going from a high, pushing 750,000 hectares, but now they're around 200,000. So that's a good news story. There's another category of countries that have high percent loss. So Nicaragua, in 1 year, 4% of its old growth, it's humid, dense, humid tropical forest cleared. These countries are really representing a cleanup operation. The proportion of protected areas and indigenous reserves that it contribute to their total area loss is much higher, because the fragments that are left have a lot of pressure on them. They're very likely, in some contexts, to be nominally protected, and then they get included in the conversion process. And then this little corner down here is the high forest, low deforestation countries, where we don't have a good policy mechanism to really reward countries for protecting their standing forests. We do a lot of sample-based estimates. For every map we make, we should do a sample-based area estimate, which has the properties of being unbiased and with known uncertainty. Maps don't have those properties. So we do half of our work is working with samples to verify the accuracy of the product, but also our maps, but also to get the story in terms of the area. So Indonesia's example is Indonesia has over 6 million hectares of idle land, and most of that idle land ends up being in palm. This is the Indonesia sample-based 30-year record where you have 0.3 million hectares per year for the last 7 years of the Jokowi administration. Prabowo is coming into power and has plans for, I think it's 12 million hectares of food estates and biodiesel. So if this might be proved to be an ephemeral success. So the idea about environmental protection is you have to win forever. We work with drivers. So this is soybean, Xiaoping Sung, producing these products. And I just want to highlight, oh, my animation's not going to work. Okay. Oh man. Okay, forget it. So, so we have in our field work, just in the last 6 years, Brazil's soybean has gone from 32 million to 48 million hectares, increased by 50%. It's insane. Since 2000 till now, they've planted more new soybean than the US has in total. Then you talk about places like Bolivia doubling in the last 4 years. And a lot of that is not in the dense forest. It's in the savannas like the Cerrado. And this is meant to be a animation. Too bad. Because we have this HLS-based 2 to 3 day repeat globally where we're mapping vegetation disturbance. And so in 2020, this animation shows all of the Cerrado in red that gets converted, but you don't have an identified land use initially. And the bright green is the soybean that came on top of that 2020 plus disturbance. So this is like EUDR relevant kind of monitoring. And that's it. Thanks.
Thanks, Matt. All right, next in line, we have Maria Macedo talking about fire and human health in the Amazon. I'm putting this microphone back. Over the people.
Okay, short. Yeah, okay. Let's see. Yeah. Okay. Hi, everyone. I'm Marcia Macedo. I'm a scientist at the Whitwell Climate Research Center and an associate scientist at IPAM, the Instituto de Pesquisa Ambiental da Amazônia in Brazil. And I am just going to share an overview of a recently funded project through the NASA Interdisciplinary Science Program that's focused on improving Amazon fire risk forecasts to reduce impacts on forests and human health. This is the project team and the main institutions. Of course, each of these people kind of connects to a whole constellation of students and institutions in the region. A lot of us began collaborating a couple of decades ago during the LBA program. Many of us were students, myself included, during LBA. And so I think this project itself is sort of a good example of how the seeds of a program like PANGEA or like LBA can kind of bear fruit long after the funding has moved elsewhere. So our motivation here is really to understand how fire is changing in the landscape. I think it's no surprise to anybody in this room that fire dynamics in the Amazon and in many places around the world have changed quite a bit over the last couple of decades. And that brings with it all sorts of challenges about, how do you manage fire in a region that historically shouldn't burn, right? These tropical forests that we're seeing burn during every major drought rarely burned in the historical record. And so we're kind of racing to catch up to this new reality. One of the features of that disturbance is smoke, air pollution, right? And that is something that creates kind of the potential transboundary issues for management, human health implications that can go well beyond where the fires are occurring. And so that's a theme that we're really exploring in this project. And kind of the other space here is thinking about what data products can we provide to fire managers to kind of help, again, improve the way that we manage fire in the landscape and try to reduce some of these impacts. people pay attention when smoke plumes from the Amazon reach Sao Paulo at 3 o'clock in the afternoon on a random weekday, as they did in 2019. But we also know that rural regions, indigenous reserves, small cities in the Amazon sit with that smoke day in and day out, and that there's not a lot of data in those places. And so that's another thing that we're trying to address in this project. I don't have results yet because we're just getting started, but just to give you a sense of the sorts of data integration that we're doing, we really have a lot of capacity that has been developed over decades in each of these research groups and in collaboration, getting quite skilled at mapping individual fires. So getting away from hot pixels and actually like looking at individual fire events, looking at fire behavior, looking at the fire line and where it might be going. So these sort of daily projections that can help with fire management and look at emissions across space. We're also, we have models that can help us get a handle on what's going to happen in the next fire season, 3, 4, 5 months ahead, and connecting that to decisions and funding streams to help actually do something is part of the challenge. But we'll be certainly leveraging the time series that we have at our disposal to kind of look backwards and forwards in predicting fires and understanding fire climate interactions, and then getting from, okay, what exactly is burning? What are the fire types? Where is the smoke going? And how does that, how does that look in terms of human exposure at local and distant? So like in urban areas far away versus locations that are close to where the fires are burning. And we will also be looking forward based on that and doing some future projections. So I'll say that none of this, there we go, that this data integration, sort of asking these questions and doing this data integration wouldn't be possible if there hadn't been, well, the satellite data, the modeling approaches and kind of the deep investment in doing research in this space. So we're now in a place where Doug Morton and colleagues can tell us on a daily timescale not only what's burning, where it's burning, but what the fire types are. So we can say something about the fuel sources, and that can tell us something about the emissions. And we're also leveraging a new low-cost sensor network that was funded through other projects, the Moore Foundation and the Mott Foundation, that are really trying to get some ground-based data in areas that didn't have any data 5 years ago when we looked at this map. One more second. And so really looking forward to kind of connecting some of these satellite-based data sets that tell us something about where emissions are going and what exposure might be like on the ground, and actually grounding that with what people are breathing at nose level day in and day out, especially at night where we don't have satellite observations. So anyway, look forward to reporting on some of those results in a future meeting. Thanks.
Thanks, Maria. And then last but not least, we have Luis Aragão and Bruce Forsberg talking about ongoing LBA efforts, and they will be online. It's a video, or are they doing a virtual live presentation?
Hi, can you hear me?
Yes, we can hear you.
Okay, are you sharing the presentation?
Nope.
Should I share my screen then?
Yes, please.
Can you allow me to do it?
We are working on that.
Okay.
And while we're doing that, I'll just let everyone know that we have gone over time, and we won't be able to make the Q&A. So if you have questions, you can ask people during the coffee break, which is going to be after this next presentation. Could you try to share now? So we have to turn off this
Okay, I
one,
think it will work. Just a second.
Okay,
Okay.
all right, it seems to be working.
Can you see it?
Yes, we can see it.
Great. So I will start. I have 5 minutes. It should be very quick. So, okay. So thank you for the invitation. I think it's great to be talking last because I think we can see what LBA have done already, because a lot of the previous speakers, they were part of LBA in the past. Paulo Brando, Doug Morton, Matt Hansen, Marcia. So you can see that the science that was developed at that time were able to really perform a good capacity building and prepare people for the challenges that we have ahead. So, talking about this, I think we are in a moment, LBA with PANGEA, with a great opportunity, as we need now to use the science for supporting solutions for the climate crisis. And aligned with this need, we have now developed in LBA the new scientific plan, which is available in Portuguese, but we can share, and I hope it can help PANGEA to also prepare its science to be done in the Amazon. So LBA in this third phase was organized in 3 topics. One is to look the Amazon as a natural environment, to be able to define the baselines required for comparing with the areas that have been transformed through time. And then we have the second topic, that's the changing Amazon environment. And then how we can manage this environment in terms of interventions that can support the recovery or the maintenance of its processes that generate services for humans. So here it's basically the main concept of the integration of these three main topics, where we have the continuous between the biosphere and the atmosphere that needs to be studied and better understood for being able to manage this system in the future. So we have the integration of biosphere, atmosphere, of course, including biodiversity, and then topic 2 that takes all these process and transform these processes in human modified landscapes. And this also must be understood using the best science that we have nowadays. And finally, the whole system is contained into a social ecological system that needs to use this resource for surviving on the planet. So LBA is organized in this way. And for developing all this research, we have an infrastructure with field sites that goes from plots, ground plots for local measurements, to towers with measurements at the landscape level, to satellites that will give the dimension of change in the whole biome. And I think for PANGEA also, it's very important to think about the data management. In Brazil, for example, we need to have data stored in Brazil as well once we have this international collaboration. So data management will be also a challenge in this project, and it has been for LBA through the time. So we need really to think about data management. So I have a lot of questions that are in the scientific plan. I'm not going through all of them, but just to have an idea of this question that may support PANGEA white paper. So we have, for example, asked what's the magnitude of the processes in the natural ecosystems, these ones that are more or less pristine, and their feedback mechanism with the climate system. People have talked about it. And what's the degree of the resilience of the Amazon reinforced in the long term in face of extreme climate oscillations and climate change? So we have done research that shows response to drought. We know about response of the productivity and mortality to drought, to temperature. We have a new infrastructure led by Davi Lapola and the collaborators. It's the Amazon phase, so is a CO2 enrichment experiment near Manaus. We have also been supporting the AFEX, the Amazon fertilization experiment that may answer several questions, especially the one that was also asked before about the nonlinear relationship between biomass and nutrients. And I can say that the key is to look at the turnover rates of these the different tissues of the plants. So if we go to the second topic, we have then questions related to what's the contribution of the Amazon as the fragmented biome transformed by humans to the global carbon balance, and how are the functioning and resilience of the Amazon modified in a landscape that is dominated by ecosystem modified by humans. So when humans are there, they change species composition, they change the functioning, and what are the impacts of these changes on the ecosystem and on the climate system. So for these, of course, we are looking at the role of degradation in the global carbon cycle. We need to include processes like selective logging, wildfires, edge effects on the quantification of source of carbon to the atmosphere, and also secondary forest growth and degraded forest as part of the sinks of carbon in this global counting of carbon in the Earth system. And also we have infrastructures that can look at the larger scale. This is a German-Brazilian infrastructure, the ATTO tower, that has a massive footprint looking at the different ecosystems that are under this footprint and looking through time at change that can be caused by human intervention and climate change on the system. So third and last theme is related to the sustainable management of the Amazon. Once we know about the change, so how can we revert or maintain the process that are going on there? So one of the questions can be, for example, how to manage the Amazon to minimize the negative impacts and preserve or recover ecosystem services. And what is the limit of the Amazon to accommodate nature-based solutions for the reduction of greenhouse gas emissions in order not to compromise food security, water quality, and availability, maintain diversity, and economically sustain local population? So all these questions are questions that science can provide an answer. And then the last slide, we have now used remote sensing to produce, for example, growth curves for forests that are growing over lands that have been deforested, so we can inform policymakers what are the areas that you can better grow forests for restoration, or what are the type of impacts that can affect the growth of these forests across the Amazon. And the last slide here is just a master thesis that was defended very, very recently, that shows that intervention with agroforestry, you can recover ecosystem services. Here shows, for example, here's the percentage of forest cover in a grid cell from 0 to 100%. And first, if you increase primary forest cover, you decrease temperature. But when you have deforested land, like with 30% of forest cover only, you also see if you increase agroforestry in this area, you decrease temperature of the land. And also with rainfall, you increase the rainfall in these highly deforested areas. And of course, in the other categories of deforested area as well. So we can really introduce our knowledge to recover these ecosystem services. So in general, LBA then is a platform that would be open for collaboration with PANGEA and bringing the infrastructure researchers to support the advance of science in terms of understanding the functioning of the Amazon in this human-modified ecosystem nowadays, and looking also at solutions to recover the functions that were lost through time in order to generate economical benefits for local population and improve the life quality of these people, not only in the Amazon, but also in the adjacent biomes that are also supported by some of the processes that occur in the Amazon. Thank you very much, and I'm open for questions if there are any. Thank you.
Thanks, Luis. Unfortunately, we do not have any time for questions because we've been sitting here for quite a while and I think we need some coffee or tea. So please be back at 4:30 for the next session where we're discussing, I think, one of the working group outcomes. End user needs for session 4.
Thank you, everyone.
All right, 4:30.
Yep. And then we go printed. We use DeepL and it works well, but it's still like I think. But like with live, you got a question. Yeah. But I do think like requiring people to do that. There's a way we can kind of thanks for doing that. But technically it was challenging.
Wow, 1 hour for the most important session, right? So let me start just by saying that I'm much more optimistic now that PANGEA will get funded, right? And then the question that we are asking ourselves during this session is, when we get funded, we are able to generate a lot of data products, what do we do of it? How do we make sure that those products are effectively used and actioned for change on the ground? So that's the underlying question to this session. And so it's and you've seen the classic terminology, end users. So initially we had planned the session for 1.5 hours. For obvious reasons, we will shorten it significantly. So we'll just do some very quick updates now, and then have around 30 minutes or so of breakout groups session. And we'll not report back, but we'll have to come back. And we've made arrangements for you to get some sort of safari tomorrow on the big outputs that you'll get out of your specific groups. So the intention is to come back here by 5:20. And we wanted to start with this kind of conversation. So we'll get funded, right? And then we'll do some research, a lot of research, but we also do a lot of training. Hopefully hundreds of students from our universities. We have a picture from people from DRC, but believe me, the intention is not just for DRC. Hopefully we'll be able to train also students in Latin America. So now the question is, how do we make sure that these trainings and all those publications in science and big journals translate into change for people, for nature, and for climate systems? How do we make that? And of course, we have some ideas about how to do it, but I'm not sure we've had enough time to think that through effectively. And our view and drawing on what we heard since yesterday, but also this morning, is that it all boils down to the users, to those who who can affect change on human, on nature, and on climate. And so that's really the big question is, how do we make sure that those users have access to this information, can influence it, and not just having access, but influence the way we do research. So this is the idea of this bi-directional conversation, not just bringing the data to users. And that's why we also decided not to call them end users, although that's the terminology, because end users, with end users, it means that you are dealing with a linear process, whereas in reality, we are in a more sort of circular process. But of course, users here is all those who can have access to the data, the information, to affect their specific duties, their specific activities, and who can also influence the way we do research. And I think we've kind of been discussing this, who qualify as users. We've started identifying government agencies, state agencies, all those who manage natural resources, civil society organizations, and the list can be much longer than what we have here. So I'm sure we all know who the users are in our specific territories, in our specific landscapes. And right now we want to start discussing who they are. There is one missing slide here, but it's fine. So maybe before we introduce this slide, it'd be good just if you want to take a few seconds to say a few words about the NASA terminology with respect to how we engage the users.
So I will just say that NASA has a section on the use of research. It's important to them. They have an action plan on it. And everybody in this room should know that, because it's not the only reason why, but it's part of the reason why we need to figure out the pathway between the information PANGEA would create and its uses at the middle, beginning, end of the project. Called Earth Science to Action. I was going to get it.
Fabulous. So right now we've been thinking about something. It's called here action flows, but the actual name we came up with was information flows to action. And the idea is that all of us here are somehow involved in getting the information to the users, in having that conversation with the users on the information. And we are also all interested in making sure that they are capable of, activating that information. And so right now, what we would like to do is to have you in your very specific geographies, start thinking about how we make sure that the users can translate this information into action. And so we have 3 very simple questions for you. The first is acknowledging that using data is very often context specific, that you just start thinking about the specific users that you have in your respective geographies. And, try to be as specific as possible. Of course, we don't have too much time, but try to be as specific as possible and start naming even institutions. So just stating that you will be working, that the government will use the data is probably not enough, because in some places we have specific agencies that are already doing a lot of work. And I'm thinking of the National Agency for Climate Change in Cameroon, for example, or AGIOS in Gabon, but they work already with very well identified actors. So it'd be good to start identifying some of those users, some of those who make action based on the data that we'll be producing here. And, action can differ a lot depending from one user to another. And so if you could just start identifying some of the key actions that you see coming up in the region based on this data, based on the kind of data that we will be producing here, that'd be great. And so you can think of actions in terms of policies, but also decisions, but even, just the intentions of a community to secure all the sacred sites. To me, that's action. And they can definitely use the kind of data that we produce to get that happen. And finally, we've been discussing very theoretically so far, like we've been saying, if you do this, it can lead to that. Now we want to bring you into some sort of exercise. As you have identified some of the main users in your specific geographies, and you've identified what they call action, like the kind of change that they want to see in the specific space. Like, that's what we call action here. Start reflecting on the specific interventions that are in between. So having the intention to change, to have a policy on, let me say, protecting specific species is very good. How do you get there? What are the specific needs, data needs that you have? But even more importantly, how do you as a research community ensure that they can use, the big paper that you've published in Science to make that change happen? And this is, bringing you to another level and helping us bring into the white paper some concrete sets of interventions that can demonstrate that we are hoping for impact, not just for outcomes, that language now. So we've thought about a very nice way of organizing groups. Virginia, do you want to reflect?
I think these are all right. Sorry, we had some changes to the slides. So because there are such significant differences by geography in governance structures, in stakeholder groups, in the ways that politics work and information flows, we are going to divide people by geography. So if people who are in the plenary room, if you look behind you, there's an Africa 1 group in this far right seating section. There's an Africa 2 group in this seating section. There's a Latin America 1 group here, a Latin America 2 group there. If that's your primary place of work, if it's where you're from, if you feel a strong affinity to it, go to one of those groups. There is also an Asia group out where we eat lunch. And then if you're thinking, gosh, like I work in the DAC, I don't have a strong geographic pull, there are global groups downstairs. So there will be breakouts that aren't specified by geography, but if you have a geographic connection, start there. The places will all have a couple of pieces of these paper, and you can put your user here and what you hope the action is with that information. And then as a group, fill in the pathway to get there. What are the different products? Who are the different actors? What are the different activities? There'll be markers and Post-its there as well. We will not have time to share back, but what we will do is take these and post them in the lobby for the coffee break tomorrow morning, so you can see what other groups came up with. And there will also be Post-its there to comment on them if you have additional ideas for user groups, resources, things like that.
Yeah, and just one final instruction is that in terms of process, right, try and make it as simple as possible. Start by listing a few actors, a few users, right? Don't start with the diagram design, because then it becomes too complicated, and then you do the same for a few set of actions, and then that's it. I think the intention was to, when you've done that, you start with one action and you do the flow for one specific action. And if you have enough time, we'll come back to another set of actions. How much time do you have? 30 minutes, right?
Yeah, I think we have 30 minutes. So take a picture before you go, because we don't have these printed out in all the rooms. And we will call everybody back up here just to say goodbye for the day and set the stage for tomorrow. So Africa, Latin America, Asia, where we've been eating, and global downstairs. There's two purposes.
So just to clarify on that, up there you have Amazon basin, but you actually mean Neotropics and Africa, right? Okay.
Yeah.
Yes.
Okay. Here's the thing I've been hoping about, like 15 I guess, because it's such a large.
You can bring your poster board to Virginia up at the front of the room. All right. There's too many things at once. So we're gonna wrap things up. Please move your chairs back. Please rearrange. Yeah, I'm just gonna close this out for the day. Maybe I'll just do that right now. So since everybody's just gonna kind of keep mingling, I'm just gonna say thank you very much for a really successful second day. And we will see you tomorrow morning at 9 a.m. Breakfast and coffee will be out at 8 again. I saw some nice conversations happening this morning. Hopefully that continues tomorrow. If anyone is still on Zoom, we're going to close for the day, and we'll see you tomorrow at 9 a.m. Eastern time. Thank you, everyone, so much. And thank you to Teodil and Virginia for leading that session. And Adia. Okay. Enjoy your evening.